Welcome to the Mathematics Paper 1 Revision Series. As you may have already seen the title and the thumbnail, in this video we will do question 1 from start to finish of this Eastern Cape June question paper from 2022. This is episode 1 or part 1 of the revision series for this paper. So each individual question will have its own episode. As you should already know, in question 1, we deal with algebra, i.e. solving for x and solving for x and y simultaneously, and then usually a more interesting question which requires you to have a good understanding of algebra. And guys, one thing that I would like to say is that you need to make sure that you take every single mark in this question. Trust me, it's not hard. It just takes practice and a good understanding of the rules of algebra. But don't worry, because in this video, you'll learn some good techniques, tricks, and tips to make sure that you master your algebra. So let's get started. So in 1.1, we need to solve for x, and 1.1.1, we have x squared is equal to negative 4x. So here you need to recognize that this is a quadratic equation because our variable x here has got a highest exponent of 2. So this is a quadratic equation. And so the first step in solving a quadratic equation is always to make sure that it is written in the standard form ax squared plus bx plus c equal to 0. And so here, in order to do so, we can carry down x squared and then transpose the negative 4x into the left-hand side so that we get positive 4x equal to 0. And now you'll notice that yes, indeed, this is a quadratic equation. A is equal to 1, B is equal to 4, but C is equal to 0, which is why we only have got 2 terms and we do not have the constant term C. It means that that term is equal to 0. And now, in order to solve for x here, you will notice that you can actually easily do it by factorization, because we've got a common factor to these terms, which is equal to x. So we can factorize by taking out a common factor of x. And after that, we'll be left with x plus 4. So this will be equal to 0. And now after this, we can use the zero product law, which tells us that we can say x is equal to 0 or x plus 4 is equal to 0, okay? Which means that x here will be equal to negative 4. And so these are the two values of x for this quadratic equation. And whenever you have a quadratic equation, you must always expect to get two values of x. And speaking of that, here is what I think is a common mistake that other learners can make in a question like this. So we have got x squared is equal to negative 4x. So you can be tempted to say that, okay, let me just divide by x on both sides of this equation. But if you do so, it means that you are making an assumption that x is not equal to 0, because we cannot divide by 0. If we divide by 0, that's a maths error, right? And if you do this, you will get x is equal to negative 4. So you'll only get this value of x. But it is very wrong to do this because, first of all, as you can see, you would only get one value of x, which is negative 4, and you have implied that or assumed that x is not equal to 0. But in fact, for this equation, one of the values of x is 0. So it means that if you do this, you are now not going to be able to obtain the second value of x. So it is very wrong to do this. Never do this. So let me write here, don't do this. No matter what, never do this when solving a quadratic equation. So let's move on to the next question. Now, in 1.1.2, we have x squared plus x minus 1 is equal to 0. And in brackets, they say correct to 2 decimal places. And here, all you need to know is that whenever you see this description in brackets, it is a clue or a tip for you that for this particular quadratic equation, you need or you have to use the quadratic formula in order for you to solve for x. So it basically means that even if you were to attempt to solve this by factorization, you would fail because you would not be able to find the factors or to factorize it. So here we will just use the quadratic formula. So we can say that A is equal to 1, B is equal to 1, and C is equal to negative 1. And the quadratic formula says x is equal to negative b plus or minus square root of b squared minus 4ac, all divided by 2a. And I'm sure that by now this is something that you already know by heart, like myself. So you do not even have to consult your formula sheet, from this to save yourself time. So let's just substitute in the values for a, b, and c. So b is 1. So here we'll have 1 squared minus 4. A is 1 and c is negative 1. And so we divide this by 2 times 1 because a is 1. And then after this, all that you have to do is to use your calculator. So we can just go straight to our calculator and input this in exactly as it is. And so we see that the answer is 0.6180 and so on. But since we are correcting to 2 decimal places, this will just be 0.62. So we've got 0.62. And then for the second value of x, we will then just change the plus to a minus, because for this one we used a plus here, but this is plus or minus, and so now we need to input a minus and see the value of x that we get. So we are getting negative 1.62. So these are the two values of x for this quadratic equation. Moving on to the next question. Okay, so here for 1.1.3, we have got quite a complex equation, because first thing we notice is that we've got square roots here, and the second term here is a fraction with the square root as the denominator. So how can we solve for x in this one? Well, so to make this easy, what you can do is you can take down the square root of x plus 4 and then transpose the second term to the other side. So we'll have equal to positive 4 divided by the square root of x minus 2. And now here we can just square both sides. And if we do that, We'll get rid of the square root on this side and we'll only have x plus 4. And then on this side, we will have 4 squared, which is equal to 16, divided by this square root of x minus 2 squared. So we'll also remove the square root there, and we will only be left with x minus 2. And now we no longer have a square root. The next thing that we need to do is we need to multiply both sides of this equation by this x minus 2 so that we move it to the left hand side. So we are going to have to put this x plus 4 inside brackets and then multiply by x minus 2. And then we need to do the same thing on this side as well. Multiply by x minus 2. And if we do so, this x minus 2 will cancel with this x minus 2, which is exactly what we wanted. And now from here, we can then expand these brackets here. And to do that, we multiply x by x, which gives us x squared. And then we multiply x by negative 2, which gives us negative 2x. And then 4 into x, which is 4x. And then 4 into negative 2, which is negative 8. And now here we are only going to be left with 16, so we might as well take this 16 or transpose it into the left hand side. So it's positive 16, here it will be negative 16, equal to 0. Because we can see already that this is just a quadratic equation. So we need to write it in the standard form in order to solve for x. And now we can just add up all the like terms. So we are going to have x squared, and then negative 2x plus 4x will give us positive 2x. And then negative 8 minus 16 gives us negative 24, equal to 0. And so, of course, from here, it's up to you. You can either try solving this by factorization or just by using the quadratic formula. So in this video, to make it more interesting, I will demonstrate how this can be solved by factorization. So the first thing is to open two brackets where we'll write the two linear factors. So it's very easy to factorize a quadratic equation where the value of a is equal to 1, like here. Because immediately we know that the first term that we need to write into each bracket is just x and x, right? Because x multiplied by x is x squared. So now the only tricky thing is to determine the suitable factors of 24 or negative 24 that we must write into each bracket. So let's see how we can go about determining that. So we can start by listing down all the factors of 24 that you can think of. So we can actually start with 24 and 1, because 24 multiplied by 1 is equal to 24. And then we can also do 12 multiplied by 2, because that can give us 24. We can also do 8 multiplied by 3, because these can also give us 24. And then lastly, we also have 6 multiplied by 4, as these can also give us 24 if we multiply them together. And now going back to the equation, we need to take note of the fact that the sign of 24 here is negative. So what this is telling us is that in these factors here, the signs should not be the same, for the products. For an example, it means that we must have negative 24 multiplied by 1, because this can give us negative 24, which is the actual value that we have. Or alternatively, we can also have 24 multiplied by -1 instead, because this is also going to give us -24. So the same thing applies for all these other combinations. But how do you know whether which factor must have the negative sign? Well, we need to consult the middle term. The middle term is positive. It's positive 2x. So the sign of the middle term is telling us that in our combinations of vectors here, the bigger number must be the one carrying the positive sign. So it means that for the first combination here, 24 must be positive while the one is carrying the negative sign. So it's good as it is. And now in the second one, it would also mean that since 12 is bigger than 2, it must carry the positive sign. So 2 must be the one that is negative, so that we get -24. So the same thing applies here. 8 is bigger, so it will be positive while 3 is negative. 6 is bigger than 4, so it will be positive while 4 is negative. So this is how we can account for the signs for our vectors. And now the next thing is to choose the correct combination of vectors here. And in order to do that, it's very easy. We should now look for a set of vectors here that we can combine to give us the coefficient of the middle term. So the coefficient of the middle term is 2. So we can go into each of these vectors and see whether which set of vectors can we combine, or to be more specific, add or sum up in order to obtain the middle term, which is 2. So for an example, if we take 24 and we sum it with -1, we are going to get positive 23. If we sum positive 12 and -2, we are going to get positive 10. If we sum 8 and -3, we get 5. And then if we sum 6 and -4, we get 2, which is exactly equal to the coefficient of the middle term. So this is the correct set of vectors that we must use in our factorization. So in one of the brackets, we must have positive 6, while we have -4 in the other bracket. So this is our factorized quadratic equation. And if you are not convinced, you can actually check if this is correct by expanding it and see if you are able to get back the equation that we were factorizing. But if you follow all these rules that I have just described, you do not have to worry at all. So this means that x plus 6 is equal to 0, or x minus 4 is equal to 0. So our values of x are x is equal to -6, or x is equal to 4. And of course, you can also check if this is correct by substituting these x values into the equation that you started with and see if the left-hand side is equal to the right-hand side of the equation. Okay, so let's go on to the next question. And so here in 1.1.4, we actually have an inequality. So we need to solve for x for this inequality. But the nice thing is that this is already presented to us in the standard factorized form. So this is going to be quite easy and straightforward for us, because we do not have to do a lot of algebraic manipulation. But it's very important to note, whenever you are provided with an equation in a factorized form like this, you must always make sure that on the right-hand side you have 0. It doesn't matter whether it is an inequality or an equation. Otherwise, if you don't have 0, then it means that you need to expand the brackets so that you can transpose this number, whatever it is, into the left hand side so that you can combine it into the rest of the expression. But for this one, we do not have to do anything because this is already set to 0. So this means that we can just go ahead and solve the inequality. And the first step in solving an inequality is to find the critical values. So this is easy for us in this case because we can see that for our critical values, we will have x plus 2 is equal to 0, or negative 3x plus 1 equal to 0. So one of the critical values is negative 2, while the second critical value here will be equal to 1 over 3. Okay, I also just want to emphasize that here I have written the equal signs on purpose. This is not a mistake, although this was an inequality. For the critical values, by definition, the critical values are the values where that particular equation is equal to 0. So I am not making a mistake here by using the equal signs. You must use the equal signs when you are calculating the critical values because that's what the critical values are by definition. Okay? And now that we have the critical values, I would propose that you use the number line method in order for you to determine the solution. So you just draw a straight horizontal line, and then along the line you need to indicate the critical values in the correct order. So here we've got negative 2 and 1 over 3. So negative 2 first, and then 1 over 3 because it is bigger than negative 2. And now the critical values again are the values where the equation is equal to 0. So we show that in the number line by writing zeros on top of these values. Okay? And now along this number line, you need to notice that we've got 3 intervals for the values of x. In the first interval, we've got values of x that are less than negative 2. In fact, let me just show it like this. So here on this side, we've got values of x that are less than negative 2. And then here, we've got values of x that are greater than negative 2 but less than 1 over 3. And then here we've got values of x that are greater than 1 over 3. And now for each of these intervals, we need to determine the sign of the expression. So for an example, we can take any value of x that is less than negative 2 and just plug it into this expression and see the sign of the number we get. So for an example, a value that is less than negative 2 is negative 10. So in fact, you can use any value that you can think of as long as it is within that range. And so now you just take the expression and substitute in this value of x that you want to use. So for negative 10, this is what you would get. So you just substitute in all of that, you punch it into your calculator, and then you look at the value that you get. So here we are getting negative 248. So in fact, we don't really care about the actual value that we get, but we are more concerned about the sign of that value. So you see that if you use negative 10, you get a value or a number that is negative. So here we then write a negative, because this is showing us that this expression is going to be negative for values of x that are less than -2. In fact, to show you that it doesn't matter which value you use, let's use another value, like for instance -4, because -4 is also less than -2. Okay, so if we use -4, we would have -4 plus 2 into -3 multiplied by -4 plus 1. So I just substitute -4 into the expression, and look at what we get. We get -26. So it's the sign that we care about. It's negative, which means that here we have a negative. And now we need to do the same thing now for the values of x that are between -2 and 1/3. So for this one, you can just use 0, because 0 is in between -2 and 1/3, and it is quite simpler. We do not even need to use a calculator for that one, because we can see that in the first bracket, we are going to have 0 plus 2, which is 2. And then in the second bracket, we would have -3 times 0, which is 0, plus 1, which is 1. So the number that we get will be +2. So we write a positive here. But even here, you can take any value that you like. As long as it is within this range, you will get a positive answer. And now lastly, we need to take a value of x that is greater than 1/3. So for an example, for this one, let's just take 1, because 1 is greater than 1/3. So we have 1 plus 2 into -3 multiplied by 1 plus 1, close bracket. So this gives us a negative number. So we write a negative here. Okay. Now that we have constructed this number line and we have determined the signs of the expression for each interval, we can go back now to our inequality. So our inequality is asking us to find values of x for which the inequality is greater than 0. So greater than 0, in other words, means that where this expression is going to be positive. That's what greater than 0 means. Something that is greater than 0 is positive. So we can say that the solution lies between -2 and 1/3. So therefore, the answer here, or the solution for this inequality, is going to be x must be greater than -2 but less than 1/3. Okay, because that's where we get a positive answer. You must also show this in the diagram, as I had already done, by showing a line from -2 to 1/3. So this line is showing that the solution to this inequality is x must be greater than -2 but less than 1/3. Okay, and sometimes you can have, for example, greater or equal to here. So if there is a greater or equal to, it means that in your number line here, you must shade these zeros to show that there is the or equal to sign, which means that the critical values are part of the solution. So if we had an or equal to, that's what we would do. But of course, in this case, our solution will be exactly like this, because we do not have the or equal to. And now 1.2, solve for x and y simultaneously. So here we've got two equations, 3 minus y plus 2x is equal to 0, and a second equation, 6x plus 4y squared is equal to 3 plus 5xy. So here the strategy in solving a simultaneous equation is that you must look for an equation that is simple between the two equations that you are provided with. And here, I'm sure we can all agree that the first one is quite simple. And now in the simple equation, of course, we have got two variables here, y and 2x. But here we notice that for y, the coefficient is 1. Or to be more specific, it is -1 in this case. So it means that it would be quite very easy for us to manipulate this equation and make y the subject of the formula. I mean, it's possible we can also do the same thing for x. We can make x the subject of the formula. But if we do so, since x here has a coefficient of 2, we would end up forming some fractions. So you do not want to complicate things by doing that. To avoid that, you must always use the variable that has a coefficient of 1 and -1 and make it the subject of the formula. So here's what I mean. Here we are going to take the simple equation that we have, which is 3 minus y plus 2x is equal to 0. And so here we can make y the subject of the formula. So to do that, we can take down -y and then transpose the other two terms into the right hand side. So we'll have minus 2x minus 3. And now we need to get rid of this negative here. And to do that, we can just multiply throughout by -1 or divide throughout by -1. And if you do that, you'll have y is equal to 2x plus 3. So this here, we can call it equation 1. And then this new equation that we have formed, we can call it equation 2. And now the second equation that we're provided with is going to be our equation 3. So 6x plus 4y squared is equal to 3 plus 5xy is going to be our equation 3. Now, you need to bear in mind that equation 1 and 2 are actually the same equation. The only difference is that we have manipulated equation 1 and rearranged the terms when forming equation 2. But technically, they are one and the same thing. So this is important for the next step, because in the next step, we are going to substitute equation 2 into equation 3, not into equation 1. Never make that mistake of substituting the new equation that you have formed into the equation that you have obtained it from. That's a very big mistake that you don't want to make. So we need to specifically substitute our equation 2 into equation 3. Therefore, we are going to have 6x plus 4y squared. But in place of y, we substitute the expression given by equation number 2. So y is equal to 2x plus 3. And we square that, equal to 3 plus 5x. And again, in place of y, we substitute 2x plus 3. Okay? And now the next thing that we need to do is to simplify this equation as far as possible. And to do that, we need to start with the brackets. So we are going to take down the 6x as it is. And then here we have got this bracket that is squared. So to simplify this, we need to take down the 4 and then start with this bracket. So if you like, you may just write this as 2x plus 3 into 2x plus 3. and then expand, because that's what the square here means. But I'm actually going to show you a shortcut of doing this in case you do not know it. So the quick way of doing it is to take the square of the first term here, 2x. So what is the square of 2x? Well, that is equal to 4x squared. And then we need to find the middle term. And to work out the middle term, we need to multiply these two terms together and then multiply by 2. So 2x multiplied by 3, that's equal to 6x, and then 6x multiplied by 2, that is equal to 12x. Okay? And then lastly, we take the square of the last term. So what is 3 squared, or 3 to the power of 2? So that is equal to 9. And so just by simply following this technique, you are able to obtain the expanded expression quickly. And now after this, we need to expand this bracket. So here it's easy. We just work out 5x into 2x, which is equal to 10x squared. And then we work out 5x into 3, which is going to be equal to 15x. And now what we are going to do is we need to expand by this 4. So we are still going to take down 6x, and then 4 into 4x squared, that is 16x squared. 4 into 12x, and that should be equal to 48x. Let's see if I'm not mistaken. So 4 multiplied by 12 equal to 48 indeed. And then lastly, 4 into 9, and so that should be equal to, I don't know, maybe 36. 9 times 4. Let's use the calculator because it's not make sure, but okay, I'm actually right. It's 36. All right. And now we might as well just move all the terms that are in the right-hand side into the left-hand side. So we'll have minus 3 minus 10x squared minus 15x equal to 0. And now from here, we need to add up all the like terms and then also write this in the standard form. So in the standard form, we need to start with 16x squared and negative 10x squared. And so of course, 16x squared minus 10x squared is going to give us 6x squared. And then secondly, we need to combine 6x, 48x, and negative 15x. So you can just go straight to your calculator. So we've got 6 plus 48 minus 15. So that is equal to 39, meaning that here we've got 39x, okay? And then 36 minus 3 is going to give us 33. All of that equal to 0. And so now we've got 6x squared plus 39x plus 33 equal to 0. And if you examine this carefully, you will actually notice that you can simplify this furthermore if you divide by 3 throughout this expression, because 3 is a common factor to all of these terms. And so if you do that, you are now going to have 2x squared plus 39 over 3. So what's that equal to? So 39 divided by 3 is equal to 13, and then 33 divided by 3, so we shouldn't forget the x, and now 33 divided by 3 is going to be equal to 11. 0 divided by 3 is 0, and now you have got a much more simpler expression. And of course, it's up to you how you solve this. You can say if you can solve it by factorization, or alternatively, you can just simply use the quadratic formula. So let's just use the quadratic formula. So we say that we've got A is equal to 2, B is equal to 13, and C is equal to 11. And so if you substitute into the quadratic formula here, we will have that x is equal to negative 13 plus or minus the square root of 13 squared minus 4 multiplied by 2 multiplied by 11. Okay, and so we need to divide all of this by 2 multiplied by 2. So after this, we can just punch all of this into the calculator and see what we get. And of course, I did not write down the quadratic formula here, but if you are going to use it, I would advise that you write the formula down first and then show the substitution. So if we plug this into the calculator, we get minus 13. Then we can start with positive 13 squared minus 4 multiplied by 2 multiplied by 11 divided by 2 multiplied by 2. And so from this we get x is equal to negative 1. And then we can work out the second value of x. So you just go to your calculator and then you change that positive into minus. And so this is negative 11 over 2, which is equal to negative 5,5. Okay, and now we have got our x values. And now we are left with finding the y values. And to do that, we can just make use of our equation number 2. Okay, because equation number 2 can give us the value of y if we know the value of x. So we can just sub in our x values into equation number 2. So that's exactly what we are going to do here. We will substitute our x values into equation number 2. And this was what we got for equation number 2. So for x is equal to negative 1, we will have y is equal to 2 into negative 1 plus 3. And for x is equal to negative 5.5, we'll have y is equal to 2 into negative 5,5 plus 3. And so here we are then going to have 2 into negative 1, which is negative 2 plus 3, that's equal to positive 1. And then our second y value is going to be 2 multiplied by negative 5,5, which is equal to negative 11. And then plus 3, that is equal to negative 9. So our y values are y is equal to 1 and y is equal to negative 9. So that's how you can solve for x and y simultaneously in this question. And now let's move on to the next one. Well, in fact, the last one. 1.3. So this says given that 9x squared minus 12px is equal to negative 4p squared, for which values of p will the equation have equal roots? Okay, and so this is about the nature of roots, and we know that if roots are equal, it means that the discriminant, which can be symbolized as delta, must be equal to 0. And of course, the discriminant is just what is under the square root in the quadratic formula. So basically, this means that b squared minus 4ac must be equal to 0. And so in order for you to be able to take the values for a, b, and c in this quadratic equation, you need to write it in the standard form first. So in the standard form, this is going to be equal to 9x squared minus 12px plus 4p squared equal to 0. So now we can see that a is equal to 9, b is equal to negative 12p, and then c is equal to 4p squared. Okay, and now we can just substitute in all these values into that equation. So we are going to have negative 12p all to the power of 2 minus 4 into a, which is 9, multiplied by c, which is equal to 4p squared. All of this equal to 0. And now what is negative 12p squared? Well, that is going to give us 144p squared. And now what is negative 4 multiplied by 9 multiplied by 4? Well, I would use a calculator for that. So we need to work out negative 4 multiplied by 9 multiplied by 4. So that's negative 144. So here we'll have negative 144p squared equal to 0. Now, this looks interesting. Well, 144p squared minus 144p squared is just equal to 0. So 0 is equal to 0. You may be asking yourself what does this mean? Well, this basically means that it doesn't matter what value we can give p here, but this is always going to be equal to 0. You can say that p is equal to 1 for an example. If p is equal to 1, we are going to have 144 minus 144, and 144 minus 144 is 0. Even if we were to say that, for example, p is equal to negative 2, we would have 144 multiplied by negative 2 minus 144 multiplied by negative 2. And this would give us here negative 288, and then on this side we would get positive 288. It's still 0, and you can do this on and on. You can try any value that you want, but this is always going to be equal to 0. In terms of the question that we were being asked here, basically it means that the solution for this question is that p can be any value. So it's the element of real numbers. It can be any real number. It doesn't matter what number it is. But this equation that we are given on this question will always have equal roots, no matter what is the value of p. So you can express that in this way by saying that p is the element of real numbers. Or alternatively, you can even say that p is an element of real numbers from negative infinity to positive infinity. So you can also use the set notation if that's what you would like to do. But either way is fine, as long as you understand what this means. So that's my 2 cents for question 1 of this question paper. I hope you have found the video helpful, and if you have watched up to this point, please don't forget to like the video. You can also leave me a comment in the comment section below, and also subscribe if you haven't done so. All right, see you on the next one, and good luck.